Good morning. Here we are at the shop on this nice rainy day. It's pouring down rain out there. What we have here is a resolver attached to a DC motor. Now normally when I test servo drives, I have a knitting machine motor whose resolver is connected to the servo drive that I'm testing, and I'll rotate the shaft of the knitting motor and spin that resolver and watch the output of UV and W fire as I rotate that resolver. And I got to thinking the other day, well, why don't I just like set up something to where I can automatically have the resolver rotating, where I don't have to do it by hand. I'm getting lazy in my old age. So I took the resolver rotor, two-part epoxied it to the shaft of this DC motor, and then epoxied the stator of the resolver to the housing of the motor. And it seems to be working fairly well. The part number and manufacturer of this resolver is Tamagawa SmartSyn, BRX SmartSyn. It's model TS2460N671E110. Very nice resolver. Now here I have a function generator, and it's set up to output a 10 kilohertz sine wave, 10 volts peak to peak, 5 volts on the positive side, 5 volts on the negative side. And that's exciting the rotating transformer of the resolver. So the red wire of the function generator is connected to the red and white wire, which is R1 of the resolver. The black wire of the function generator is connected to R2, the yellow and white wire. Now channel 1 of the oscilloscope, this is our sine up here, channel 2 is our cosine. And the sine is on S2 and S4. S2 is the yellow wire, S4 is the blue wire. And the cosine, channel 2, is connected to S1 and S3, S1 being the red wire, S3 being the black wire. Now I have the black and the blue wires, S3 and S4, connected to ground of the oscilloscope. And again, channel 1 is connected to the yellow wire, S2. Channel 2 is connected to the red wire, S1. Now hopefully I didn't get my sine and cosines backwards. That happens sometimes. Get confused with S1, S3, S2, S4. Who's sine, who's cosine? But we can go on the internet and find out for sure. Let's set this aside and we'll go look at the waveforms on this oscilloscope. Then we'll go up to this oscilloscope up here, set it to XY mode, and you can see the resolver's waveform in XY mode. Now I use this scope for XY because if I set this scope into XY mode down here, it's a little bit fuzzy, hard to make out, but that one up there is nice, sharp, and clear. The problem I do have with this oscilloscope is the rotary selector switches and whatnot. I need to take that scope apart and spray them out with some contact cleaner. They're a little bit noisy, so sometimes the waveform don't show up quite right because of the switch connections and the pot connections and all that. I'll do that someday when I've got time. Let's come over here and take a look at these waveforms. The amplitudes of the sine and cosine increase to maximum and decrease to minimum. And the phasing between the sine and cosine also changes. The sine and cosine are either in phase or 180 degrees out of phase. And from the amplitudes and the phasing, we can determine the position of that resolver. Let's move over to the other oscilloscope and we'll look at this resolver in XY mode. This is going to be fascinating. This always blows my mind when I look at these things in XY mode. Now I'm going to rotate that DC motor shaft by hand and we'll look at the waveforms. Now right there, sine is at maximum amplitude and cosine is at minimum. Here we are, both are about equal and out of phase. You can see up here that the sine is at min and the cosine is at max at this point right here. We just lost the trigger. Okay, now we're in phase. So out of phase and in phase, both phasing are equal. Okay, I'm going to start that DC motor. We lose the trigger down here. When the sine is at minimum, we lose the trigger because we're triggering on the sine. See if I can change that trigger. We'll trigger on cosine. Get over here to the oscilloscope. Where are we at? Trigger on channel 2. There we are. Okay. Now when the cosine is at minimum, we lose track on the sine. Let's go back to channel 1 triggering. Now I'm going to set the oscilloscope in XY mode. Okay, let's move to the center. Bring that up. Move a little bit over to the center right there. There we go. This is the waveform that we see of the sine cosine on channel 1 and channel 2 in XY mode. Now the shaft, looking into the shaft of the DC motor, it is moving counterclockwise. And you can see our waveform on the screen is also moving counterclockwise. Now I'm going to stop the DC motor and swap the polarity into the DC motor so that it runs clockwise, and we'll see what our waveform looks like. Look at this. Now our DC motor is running clockwise and our waveform in XY mode, the sine cosine, it's running clockwise. Clockwise on the motor, clockwise on the waveform. Speed that motor up. Moving at a pretty good clip right there. We'll slow everybody back down. Okay, we're just creeping along. I've got me a new tool. Resolver attached to a DC motor. So I don't have to rotate that resolver by hand anymore. Sweet! Yeah, sometimes I think of some good stuff. Every now and then. Oh, let's do a little bit of experimenting. What if we were to lose, say, let's see. Let's say we lose the sine. Okay, I'm going to disconnect the sine. Okay, this is just cosine. Unless I'm backwards. Let me look at my sheet of paper again. Okay. That's 2 sine. Yes, I disconnected the sine. Let's hook the sine back up. Now we have sine, cosine connected, and I'm going to disconnect the cosine. That's what our waveform looks like with just sine connected. Let me hook the cosine back up. There we go. Amazing. So if your scope has XY mode, you can look at your resolver in a different fashion than we normally see. All right, all. Stay safe out there. We got that hurricane coming up this way. Supposed to get to us tomorrow. And stay dry. Be careful, folks. It's a dangerous world we live in. We'll see you in the next one. Here we are, day 2 with our Tamagawa resolver. What we're going to do today is we're going to compare the waveforms, sine and cosine. We'll look at that, and then we'll look at the position of the waveform in XY mode. And we'll see that when, for instance, when the sine is at minimum and the cosine is at maximum, the XY waveform will be at 0 degrees. And then when we move the resolver, I'm going to rotate it by hand, we'll go through like 45 degrees, 90 degrees, 135 degrees, 180 degrees, and we'll look at the sine cosine waveforms and the XY waveform. So we're going to be jumping back and forth between normal 2-channel view and XY mode as we rotate through the different positions of that resolver. Fire up our oscilloscope, and we're going to get closer to everything so you can see what's going on. This is going to be fascinating. This is actually trigonometry in action. If you ever wondered why you took trig in college, this is one of the reasons. Here we go. Here we're back to 2-channel view with the sine on top and the cosine on the bottom. The sine is at minimum and the cosine is at maximum amplitude right there. I'm going to reach over here and set the scope to XY mode. And you can see that our waveform is straight up and down. And we're going to call this point up here 0 degrees of the unit circle. And we're going to rotate through 45, 90, 135, and 180 degrees. Okay, let's go back to our view right here. Now, let's rotate the resolver. See which way am I going? There we go. That looks like 45 degrees to me. I'm going to shift this over a little bit so we're kind of centered on that XY axis. Let's go back to our standard view right here. Now notice that the amplitudes are the same. And at 45 degrees, the sine and cosine, 45 degrees, is 0.707. So this value of voltage right here would be 0.707 of the max amplitude. 70.7% of the max amplitude. And notice that the way we have it set now, we're out of phase. Let's go back to XY mode, and we're going to rotate to 90 degrees. That's about as close as I can get it. That motor wants to detent a little bit on those brushes. Okay, let's go back to our 2-channel view. We're going to trigger on channel 1, and now look at this. At 90 degrees, the sine is at max amplitude, and the cosine is at minimum amplitude. And that is trigonometry. So the sine of 90 degrees in the unit circle is 1, and the cosine of 90 degrees in the unit circle is 0. Let's go back to XY mode, and we're going to rotate to 135 degrees. It's about as close as I can get. Let's shift it over so we're centered again. We'll go back to our 2-channel view, and the amplitudes are the same, and now we're in phase. Isn't that something right there? Let's go to 180 degrees. We're back vertical. There, that's pretty close to straight up and down right there. Let's see what we have. Let's trigger on channel 2. And again, at 180 degrees, the sine is at minimum and the cosine is at maximum. 180 degrees, pi. 90 degrees, pi over 2. What is 45 degrees? That's pi over 4, I think. It's been a long time since college. I got to get trigonometry for dummies. Refresh my memory. But there we go. There's 2 ways you can look at your resolver waveforms. You can look at it in 2-channel mode, which is what we've got on the display, or if your oscilloscope has the option, you can set it to XY mode. You hear that rain out there? Rain on a tin roof. Nice. I'm rotating that resolver by hand. Okay, now what we've got to do, I don't know if I'll make a video of this because it's going to be very complicated. I got to troubleshoot a bad firing channel on a Yaskawa inverter drive, a GPD 505. I think it's a P5. Well, if it gets too complicated, I'm not going to make a video because that could be an all-day affair right there. Alright, all. Stay dry. Stay safe. We're under a flood advisory around here, and the roof's leaking. I've been moving equipment in here in the shop out from underneath of the roof leaking. Okay. Oh well. We'll see you in the next one.